last night.
Okay, so today we're going to be solving some trig equations. And so I've already informed you that you need to take out your pink sheet with all of your nice little angles and all that, because that is going to help you immensely on today's homework.
What if we have a white sheet?
So that's fine as long as you have this stuff done. If you notice up there, we're going to solve 4 sine x equals 2 sine x plus root 2. So our utmost goal is going to be to get a trig function all by itself on one side and then everything else on the other side. And so if you notice here, I've got 2 trig functions. Okay. So what we're going to do is we're going to go ahead and combine the signs. So let's go ahead and subtract 2 sine x and move it over here to the left. And when I do that, what am I left with on the left side?
2 sine.
2 sine x equals root 2. So now what do I do? Divide by 2, because if you remember, our utmost goal was to get a trig function all by itself on the left side. So sine x equals root 2 over 2. So now, using your pink sheet, you should notice that in the sine column there are 2 values at which you get root 2 over 2. And what are those 2 values? Pi over 4, and we always answer these in radians, by the way. Pi over 4, and what was the other one?
3 pi over 4.
3 pi over 4.
That's it?
What do you expect the next one is going to be?
6 pi over 4.
5 pi over 4. What is 5 pi over 4 going to be?
Negative root 2 over 2.
Negative root 2 over 2. So that it doesn't work as the pattern. It's going to go 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And so actually what I'm going to do is I'm going to have 2 separate answers here. Oops, I wrote that one wrong. Okay, the first answer is going to deal with the pi over 4. And what I need to do is answer for all possible values. And so what I'm going to do then is go ahead and add or subtract 2 pi n. Now n is any number, n is any integer. And so what this does is this takes into account all the possible solutions, because these are actually coterminal angles. Whenever you add the 2 pi, that is a coterminal angle. Now the 3 pi over 4, I'm going to do the exact same thing. And the last thing I need to do is preface that n is an element of the integers. Okay, and so that's what that NEZ is. Remember that n is what's up above, e is an element, and z is the integers. And so that is going to be your final answer. Okay, now that's going to kind of look a little foreign right now. We'll go ahead and look at another example and see what we come up with. So let's look at this one. 5 cosine x equals 3 cosine x plus root 3. So minus 3 cosine x, very good. So that's the very first step I'm going to do. So on the left side, I'm left with 2 cosine x. On the right side, I get root 3. What do you do now? Divide by 2. So I end up getting cosine x equals root 3 over 2. What values, using your pink sheet? 2 pi over 3. And what's the other one?
Oh, pi over 3.
Pi over 3 and 2 pi over 3. Okay, so now in looking at the pattern, the next value, if I went pi over 3.
I was looking at
That's
sine.
wrong.
Oh my gosh.
Yeah.
Let's
Christina.
try again, okay.
Pi over 6.
It's 1/2.
Okay, where's
Oh,
cosine root
pi
3
over
over
6.
2?
Pi over 6.
The answer should be pi over 6, okay. And the other one should be 11 pi over 6.
You do anything right, Christina?
And so now what I'm going to go ahead and do is I'm going to go ahead and write my answers down here. So I've got pi over 6, 11 pi over 6. What's my answer going to be? Pi over 6 plus or minus
11 pi over
2 pi n. And then 11 pi over 6 plus or minus 2 pi n. And now n is an element of the integers. And there you go.
Is it always 2 pi n?
pretty much it's always 2 pi over n. There might be a time, and that's what we're going to talk about, when you might only add pi over n.
So this isn't that bad.
No, it's not that bad. Let's look at this one. 4 sine squared x plus 1 equals 4.
That Coke looks so good right now.
Okay, so then now what do you do to solve this?
-1, I'd say, from the left side first.
Subtract 1 first. Good. So then I'm left with 4 sine squared x equals 3.
Read that bad boy.
What should you do now? Divide by 4.
Yeah.
So that I end up getting sine squared x equals 3/4. Now what do you do?
Square root.
The square root. Now what is the most important thing to remember whenever you take the square root?
Square root of both top and bottom.
That too, there's always one thing I told you never to forget whenever you take the square root.
Plus or minus.
Plus or minus. Good. So on the left side you end up getting sine x. On the right side I end up getting plus or minus. On the top I get root 3. On the bottom you get 2.
Ooh, I
Okay, because the square root of 4 is 2.
see.
Because really what this means is it means root 3 over root 4.
You can. Simplify right
So
there.
then now, I'm going to look at the sign column. Where does it equal root 3 over 2? Positive or negative?
Pi over 3.
Pi over 3,
2 pi over 3.
2 pi over 3. What's another one?
4 pi over 3.
4 pi over 3,
And 10 pi, or 5 pi over 3.
5 pi over 3.
Can you just
Now, in looking at those, let's go ahead and look at those. In looking at those, you know that there's a pattern.
Plus
Okay.
1 plus
Pi over 3 to 4 pi over 3. What are you adding on that one?
3.
You're adding what?
3 pi.
How about 1 pi?
1 pi.
You're adding 3/3,
Oh,
which
yeah.
is 1 pi. What am I doing from 2 pi over 3 to 5 pi over 3?
Adding a pi.
You're adding 1 pi. So in this case, what I'm going to do is I'm only going to have 2 answers here. The first answer is going to have a starting point of pi over 3. So pi over 3 plus or minus. What do you think I'm going to add there? 1 pi. The reason why I'm only going to add 1 pi n is because if I add 1 pi, it goes to 4 pi over 3. Then if I add another 1 pi, it will be back at pi over 3 again. Okay? Now my next one is going to have a starting point at the 2 pi over 3. And what am I going to add to 2 pi over 3?
1 pi.
1 pi n again. And n is an element of the integers. Okay? So that's a case of where you don't add the 2 pi. You can just add 1 pi. So no count all of those. Questions? Got 2 more of these we're going to look at, and then I'm going to let you go.
Can you skip these two?
Okay. Now these 2 are going to be a little bit different. If you notice this one,
Oh,
two.
so it's
Good thing we brought this. No.
now, I know a lot of you are probably thinking that in order to solve this, you're going to divide by cosine. Can't do it.
Why not?
That's just not.
Because you end up losing a solution. So what you're going to do, you cannot divide by a trig function. If you divide by a trig function and it eliminates the trig function, you're going to lose a possible solution. So if I subtract it, I end up getting cosine x times sine x minus 3 cosine x, and that's going to equal what? 0. So then now you have 2 quantities. So what do you notice about each of those quantities? They each have a cosine. So I'm going to go ahead and factor a cosine out. And when I take that cosine out, I'm left with sine x minus 3. Now what ends up happening is, okay, this is the zero product property in play. And the zero product property states that either cosine x equals 0, okay, that's one solution, or it states that sine x minus 3 equals 0.
Which means sin x.
So now, if you would have divided by cosine, you would have eliminated the green solution totally from your answer. And so that's why we have to factor out in this case. And so now, on your chart, where does cosine equal 0?
0.
pi over 2 and 3 pi over 2.
Pi over 2 and 3 pi over 2. So what do you notice about the difference there?
That's a full pi.
That's a full pi, so our answer here will be pi over 2
Entire pi.
plus or minus
1 pi.
1 pi n. Yep, that's one solution. Now what we have to do is solve the yellow solution as well. And to solve the yellow solution, we get sine x to equal 3. Where does sine equal 3?
0 pi and
2 pi. Oh, never mind.
Where does sine equal 3?
Nowhere.
Nowhere. Why doesn't it equal 3?
Because it's greater than 1.
Because it's bigger than 1. Remember, sine only goes between -1 and +1. So the last thing you need to do is make sure that you get n as an element of the integers in there as well. And that's going to be your final answer. See, now if you would have divided by cosine, you would have ended up getting a no solution on this problem. So, can't divide by a trig function and eliminate the trig function. Very last one we're going to look at. And then we're done for today. Cosine to the 4th x plus cosine squared x minus 2 equals 0. This is a quadratic, but it's in a little different form.
Add 2.
Okay. Real similar to this. And so what I need to do now is factor it using this. So I'm looking for 2 factors of 2 that do what?
Equal to.
Differ by
1.
1. So 2 factors of 2 that differ by 1. What are they? 2 and 1. How do you get a positive 1 from 2 and 1?
-1, +2.
-1, +2. So now what I'm going to do is I'm going to now translate that over to the left. And so I've got 2 quantities. The first term in each of those quantities, can somebody guess what that's going to be? Cosine squared, yep. So cosine squared x is going to be the first term in each of those quantities. What's going to be the next term? Plus 2 and then minus 1. Oops, there we go. And so now, according to the zero product property again, I can go ahead and break those down. The first answer is that cosine squared x plus 2 equals 0, or cosine squared x minus 1 equals 0. And so now I'm going to treat these individually and solve each one of them. So what's the first thing you're going to do to the blue one?
Add 2 or
Subtract 2. So you end up getting cosine squared x equals -2. So now what do you do? Square root it?
No.
So you end up getting cosine x to equal what?
Root 2, 0.
The square root of -2.
You
You can't take the square root of -2. So this one is done. You can't take the square root of a negative number. So now we basically have this as our possible solution. And that's that cosine squared x equals 1. What do you do now?
Square root.
Square root it. Now what's the important thing to remember with square root?
Plus
Plus or minus. So now I know that the cosine of x equals plus or minus 1. So on your pink sheet, what values make that statement true?
0 pi, 2 pi.
Try again.
0 and 2 pi.
0 and what?
2 pi.
0 and what?
Pi.
Pi.
Why not 2 pi?
And 2 pi does work. 2 pi does work. You can put 2 pi down
Okay,
too.
thank you.
Okay, but look at the difference between all those. What is the difference from here to here to
Full
here?
pi, entire
1 pi. So my answer will be
Pi plus
Pi.
0 plus or minus
Pi.
1 pi n. So really, do you need the 0?
No.
No, not really.
Plus or minus.
You could have it, but you don't need it.
I prefer it.
And there you go. That's your final answer. Okay, so now, as you can see, we rattled through these fairly quick. So your assignment is gonna be a little longer in terms of numbers. It's on page 331, 1 through 18. Okay, 331, 1 through 18.
There's only 9 of them, guys.
Are we adding that? Sorry.
No, you're not adding that. That is a totally new assignment.
Yeah.
Now